Hello trainees, welcome. In this session, we will learn to check the condition of electrolyte in a solar battery using hydrometer and add distilled water to the required level in the solar battery. At the end of this session, you will be able to describe the role of solar battery in solar energy system, understand the need to check the condition of electrolyte in a solar battery, identify with the instrument needed to measure electrolyte of a battery, and understand why it is necessary to monitor the electrolyte in solar batteries.
Solar energy is one of the renewable and reliable energy sources which can meet the energy demand of future to greater extent. Solar batteries store the excess energy generated by your solar panels, which can then be used to power your home during gloomy, rainy days or after the sun sets. When solar energy is pumped into a battery, a chemical reaction among the battery components stores the energy. The reaction is reversed when the battery is discharged, allowing current to exit the battery. Solar batteries increase the reliability of solar power systems and decrease dependence on the conventional power grid. The ability to store and utilize solar energy even during periods of limited sunlight makes solar power a more practical and efficient choice for renewable energy. Several factors affect the performance of the solar battery. They are type or material, battery life, depth of discharge, and efficiency. The four main types of batteries used in the solar power are lead acid, lithium ion, nickel cadmium, and flow batteries. Among the four, lead acid batteries and lithium ion are commonly used. Lead acid batteries are used in automotive and industrial applications. They have a low energy density but remain both cost-effective and reliable, while lithium-ion batteries have a high energy density and offer a smaller, lighter, and more efficient option. They allow the user to access more of the energy stored within the battery. Solar batteries require regular and careful maintenance for a longer battery life. Battery life can be extended if it is kept at high state of charge, not over discharged, or operated at excessive temperatures over 35 degrees Celsius. Properly maintained battery state of charge is key to maximizing battery life. A very low state of charge implies that less electricity energy is stored in the battery. The longer the period of low state of charge, greater the chance of sulfation buildup on the plates. This results into shorter battery life. Shown here is a hydrometer that is used to determine the density of a liquid. It usually consists of a glass float with a long thin stem which is graduated. The glass float is a large hollow bulb which increases the buoyancy so that the hydrometer floats. The narrow stem increases the sensitivity of the hydrometer. The bottom of the hydrometer is made heavier by loading it with lead shots so that it floats vertically. A hydrometer is used to measure the concentration of sulfuric acid, specific gravity of battery electrolyte, battery acid. You can easily and accurately determine a non-sealed battery's state of charge. It sinks less in a denser liquid and more in a lighter liquid. The lowest density is marked on the top of the stem of a hydrometer, and the maximum density is marked at the bottom of the graduated stem. Please note to check the electrolyte level and to ensure that it is above the plates in all cells. If it is below the plates, The test cannot be carried out until water is added and the battery is charged to mix the water and residual acid in the battery. It is important to ensure that the plates do not remain exposed to air and are allowed to dry and oxidize. The procedure to be followed to check electrolyte in solar battery and add distilled water is as follows. Ensure you have all the following tools and equipment: hand gloves, hydrometer, distilled water and lead acid battery. Submerge the lower end of the glass tube, which is connected with a narrow tube made of acid resistant material, in the acid which is in the accumulator. Press the rubber bulb so that the air inside escapes from the narrow tube at the other end of the glass tube. Observe that as the pressure is removed, there is a partial vacuum in the glass tube and the acid pushes up into the glass tube. Now the hydrometer floats in the acid. Read the density of the acid on the floating hydrometer. Make observation based on the reading. Please note the acid in a fully charged cell should have a relative density of 1.25 to 1.30. A reading of less than 1.18 indicates that recharging is necessary. Remove the surface charge if the battery has been charged within the last 4 hours. Remember, if the battery has been discharged within the last 15 minutes, wait for at least 15 more minutes before testing it. Squeeze the rubber bulb to release the electrolyte back into the battery cell. To increase the accuracy of the measurement, in the same cell, repeat this process several times so that the float will reach the same temperature as the electrolyte. At eye level and with the float steady, read the specific gravity at the point the surface of the electrolyte crosses the float marking. Release the electrolyte back into the cell from which it was taken. Be sure to avoid spillage and thoroughly rinse the hydrometer with water after using it. Here are some do's and don'ts of adding distilled water to the electrolyte. Only add distilled water to the electrolyte. Do not add acid. Do not add water with impurities, as these impurities will accumulate over time and will cause problems. Do not take a specific gravity (SG) reading just after topping up with water.
We have reached the end of this session on how to check the condition of electrolyte in a solar battery using hydrometer and adding distilled water to the required level in the solar battery. By now, you should be able to describe the role of solar battery in solar energy system, understand the need to check the condition of electrolyte in a solar battery, identify with the instrument needed to measure electrolyte of a battery, and understand why it is necessary to monitor the electrolyte in solar batteries.